Alright, so let's draw a sketch. We got angle C, acute 40 degrees. So lowercase a and lowercase b will be the two adjacent sides because lowercase c would be the opposite side. So I'll just call the bottom 26 and the other one 14. Okay, so I don't really know what C looks like, but I'll just guess it's right here. Okay, so we have a side angle side, which means we cannot use the law of sines because we don't have any angle side pairs. So we can use the law of cosines instead. So I'll start with the side. Okay, and substitute in all the values. Okay, and then since I want c squared, I will square root both sides. Okay, so this gives us c is 17.729. Okay, so now to get the other two angles, I can either do law of cosines again, or I can do law of sines. So remember, if I want to do law of sines, I should do the smaller angle first because it's guaranteed to be acute. So looking at the side lengths, 14 is shorter than 26, so angle B will be smaller than angle A. Okay, so I'll use law of sines. Again, you could do law of cosines instead. Okay, so then solving for B, cross multiply, divide, do the inverse operation. Okay, so this gives you B is 30.5 degrees. And then finally we can use the triangle sum theorem to get angle A. Okay, 180 degrees minus the two angles we know means there are 109.5 degrees left over for angle A. Okay, so again with SAS, I know there's just a single triangle, so I don't need to check how many solutions there are. Okay, triangle B, we're given SSS. So again, if it's possible, there's only one triangle. So let's see. Looks like side C is the longest. Okay, so looks like we're gonna have to do law of cosines because again, law of sines won't give us any pairs. So it doesn't, no, sorry, we should start with the biggest angle. So in case it is obtuse, because law of cosines correctly identifies obtuse angles. So the longest side is C, so the largest angle will be letter C. Okay, so use the version of the law of cosines which solves for C. Okay, so fill in the values. Okay, let's see what this equals. Okay, so it looks like C is 96.38 degrees. Okay, so now to get the remaining angles, at this point I know they're both acute because there can only be one obtuse angle per triangle. I can either do law of cosines a second time, or I can switch to law of sines. So why don't I do law of sines? So sine of C over side C equals sine of angle B over side length B. So cross multiply and solve for B. Okay, so we get B is 48.19 degrees. And then once we know two angles, we can just use the triangle sum theorem. So subtract the two known angles from 180. And that gives us 35.43 degrees left over for A. Okay. So let's see, we got angle A, acute. Opposite side is 7, which I don't know, and then adjacent side is 8. Okay, so I'm given SSA, so I do need to check how many solutions I have. So first I'll find the height, h. Okay, so looking at just this right triangle, sine of 20 degrees is h over 8. So then h equals 8 sine of 80 degrees, which is 2.74. Okay, so the swinging arm, the opposite side of the given angle, 7, is greater than the height. So that means that this is a possible triangle and it's not a right triangle. Okay, but now I need to check the swinging arm against the other given side. So 7 is less than 8. So the swinging arm is shorter than the other given side, which means it has room to both swing out and swing in. So this time there will be two solutions. Okay, so one of them we know will be acute. And then the other one, B, will be obtuse. Okay, so we can start with law of sines. Okay, so when we type this into our calculator, it gives us a B value of 23 degrees. Okay, so for the acute triangle, that's fine. But we know that for the obtuse triangle, it will be the angle whose reference angle is 23 degrees. So 180 minus 23 means for the other triangle, B is 157 degrees. And sorry, we already knew 20 degrees for A that was given. Okay, so let's just go ahead and find the third angle. So 180 minus 20 minus 23 leaves 137 degrees for angle C in the first triangle. And then in the second triangle, we have 180 minus 157 minus 20 leaves only 3 degrees for the third angle. Okay, let's find those missing sides. So back to the first triangle. Again, we could do law of cosines or law of sines. I'll do law of sines. Okay, so typing this into the calculator, I get 13.96. And then over on the other triangle, set up the law of sines. So sine of A, I know what A is. A is 20 degrees. Over side A equals sine of angle C over unknown side C. Okay, so it looks like C will be, for the other triangle, 1.07. All right, so let's see, we got a 40-degree angle. The opposite side is 4. One of the adjacent sides is 7. Okay, so I'm given SSA, so I need to check the solutions. So the height, so sine of 40 degrees equals h over 7. So then 7 sine 40 degrees equals h, and my calculator tells me that's about 4.5. Okay, so this triangle is impossible because if the height's 4.5 and B is only 4, B won't be able to reach the base. So this is impossible.